The A320 pneumatic system supplies high-pressure hot air for air conditioning, wing anti-icing, water pressurization, hydraulic reservoir pressurization, engine starting, and, if installed, the aft cargo heating. High-pressure hot air can be supplied from 3 sources: the engine bleed system, the APU, an external high-pressure ground power unit. Note: wing anti-icing is not permitted when the pneumatic system is supplied by the APU bleed.
The pneumatic system is controlled and monitored by 2 bleed monitoring computers, BMC. There is 1 BMC for each engine bleed system. Both BMCs are interconnected, and if one fails, the other takes over most of its functions.
An ambient overheat in the vicinity of the hot air ducts, in the fuselage, wings, and pylons will be detected by air leakage detection loops. If a leak is detected, a signal is sent to the BMCs, which automatically isolate the affected area.
In flight, the primary source for high-pressure air is the engines. Both engines have similar bleed systems. Air is bled from 2 compressor stages of the engine, the intermediate pressure IP port and the high pressure HP port.
There's an HP valve, which can cut off bleed air from the HP port. It is automatically controlled by the system and will limit the downstream pressure. Note: there is a non-return valve at the IP to protect the compressor against a reverse flow from the HP. The high-pressure section, HP, is only used when there is insufficient pressure from the intermediate pressure output, IP, due to the low engine compressor speed. Once the engine compressor speed is high enough, the IP is sufficient and the HP valve closes.
The air extracted from the compressor then goes to a bleed valve, which acts as a shutoff and pressure regulating valve.
Since the temperature of the bleed air is high, it passes through a precooler before being distributed to the users. The precooler heat exchanger uses cooling air, bled from the engine fan, to regulate the temperature according to the demand. Note: an overpressure valve, OPV, will automatically close in case of pressure regulation problem. Engine 2 has an identical bleed system.
Both systems are connected by a cross-bleed duct. A cross-bleed valve permits their interconnection or isolation. The APU can also be used for bleed air supply. This is usually done on ground for air conditioning and for engine start. However, APU bleed air is also available in flight.
APU bleed air is controlled by the APU bleed valve, which operates as a shutoff valve. Note: a non-return valve protects the APU compressor against a reverse flow from another supply source.
Should the APU not be available, a high-pressure ground power unit can be connected. This completes the pneumatic system. We will now show you how system information is displayed to the pilots. Information on the pneumatic system is displayed on the lower part of the ECAM bleed page. Note: we have shaded the upper part of the ECAM bleed page because it is related to the air conditioning chapter. This will be covered in a later module. Let's identify the system components on the ECAM page now. The IP and HP ports, the HP valves,
the engine bleed valves, the precoolers, the APU bleed valve, only when APU is running, the cross bleed valve, and the high-pressure ground indication, always displayed on ground even if the ground unit is not connected. The following information is also displayed: precooler inlet, air pressure, precooler outlet, air temperature, and engine identification numbers.
Controls for the pneumatic system are part of the air conditioning panel, located on the overhead panel. Again, we have shaded the controls which belong to the air conditioning chapter. Each engine bleed valve is controlled by its associated push-button switch on the air conditioning panel.
The APU bleed valve is controlled by its related push-button switch. The cross-bleed selector switch enables the pilot to open and close the cross-bleed valve manually, or to let the system operate the cross-bleed valve automatically. Usually, the APU bleed air is used to start the engines. The APU is connected to the bleed system. You are ready for engine start. Notice that the engine identification numbers have turned white, indicating that the engines are running. The engine bleed valves remain closed because the APU bleed valve is open, and the APU has priority over the engine bleed. We can now switch the APU off. Observe the ECAM. The APU bleed valve is closed. The cross-bleed valve is automatically closed. It is displayed amber during transit. The engine bleed valves and HP valves are displayed in line green because they have been automatically opened.
We will now talk about the changes that occur in the pneumatic system during takeoff. Note, normally, the ECAM engine page is displayed for takeoff. For training purposes, we will display the ECAM bleed page. As engine thrust is increased, the pressure delivered from the IP stages is sufficient, and the HP valves are automatically closed accordingly. If the APU is inoperative for bleed air supply, a ground HP air unit can be connected to provide pneumatic pressure for engine start. The ground unit's pressure and temperature are indicated on the ECAM.
Notice that, in this case, the cross-bleed valve remains closed with the cross-bleed selector switch in the auto position. In order to start engine 2 first, you have to manually set the cross-bleed selector switch to open. This is done according to a procedure in your FCOM Pro Sub 70 section.